Okay, we're going to be continuing on with geometric sequences. We've done something very similar to this before with arithmetic sequences where we add to get from one term to the next. We're continuing with geometric, so this time we're looking at these missing term tables with the idea of multiplying. So we have to ask ourselves, we start at a 3 and we multiply by something 1, 2 times to get to that 12. So we start at the 3. We multiply times r times r. So the way you represent repeated multiplication is using an exponent. So if we do 3 times r, it's going to equal 12. So because that 3 is multiplied by that r squared, we have to divide by it to get rid of it, and we're left with r squared equals 4. So now you would use your calculator in order to do the square root of 4. So opposite of squaring something is taking the square root. And the square root of r squared is r. The square root of 4 is 2. So that lets us know that we're multiplying by 2 to get from one term to the next. That's your your common ratio. So 3 times 2 is 6. 6 times 2 is 12, which meant we made it to where we intended to go. Now it says, is this the only missing term? Is that missing term you identified, that 6, is that the only answer? And why or why not? In this case, it's not. Because if I use the exact same table and I multiplied by a -2 instead of a +2, I would have ended up with -6 times -2 would still give me a +12. So no, in this table, r could also equal -2. So now if we look at table 2, this one has an additional missing term. So we start off with our 7. There we go. So we start off with the 7. And then we multiply r times r times r. So to get to the second term, the third term, to the fourth term. So exponents represent repeated multiplication. So we have r times r times r. So that's r to the third power because there's 3 r's there. And that's going to take us to 875. So same as before. That 7 is being multiplied by the r cubed. So we have to divide by 7 on both sides first. And then we're left with r cubed equals 125. Now, because this has a 3 in the exponent instead of a 2, you're going to have to do something a little different in your calculator. So above the square root button, so there is the x squared button that has a square root in the background. Above that, there is a button that has a thing called a caret, which means you can put any exponent you want. And behind that in green, it has x square root. So that's what you're going to use here. But first, you have to hit the 3. So what you're going to type into the calculator is 3. Then you're going to hit that second button. And then you hit that caret button. And then you type in 125 and hit enter. When you hit enter, it's going to give you that r equals 5 because that's the cube root. So again, you have to hit 3, then second, then that caret, and then 125. Hit enter and it'll tell you that the number you're multiplying by is a 5. So when we go back to our table and we check this, we have 7 times 5 is 35. Times 5 gives us 175. Times 5 gives us 875. That's exactly where we needed to be. So if this had been a negative 5 instead of a positive 5, would that also have worked? So we have a 7. If we did times negative 5, so I'm going to build the table again. So if we had tried a negative 5 to see if that positive 5 is the only answer, that would have given us negative 35 times negative 5 would give us positive 175 times negative 5 does not equal that. So in this case, yes, R can only be 5. Because if we multiplied by a negative 5, that 875 would have to be negative, and it's not. So a negative 5 would not work. So we come on down to the next one. And I'm going to add a little room to the right side of my paper just to make sure I have plenty of room to write. So on this one, we're starting off at a 6. So that's the first thing I'm going to write. There we go. So we're starting off with a 6. And then we're multiplying. So to get to the second term, to the third term, to the fourth term, to the fifth term of 96. So we have 1, 2, 3, 4 R's. So we use an exponent 4 because exponents represent repeated multiplication. And that takes us to 96. So now you solve this just like you've solved all the rest. It says 6 times r to the fourth, so we have to divide by that 6 to get rid of it. And then we have r to the fourth equals 16. So just like we did on the previous one, on this one, your exponent goes first, so you hit 4, second, caret, 16, and then enter. And it'll tell you that r equals 2. So when we go back to our table, we have 6 times 2 is 12, times 2 is 24, times 2 is 48, times 2 is 96. Perfect. Now, could this r value have been a negative 2? So if we had 6 times negative 2, that would give us negative 12. Times negative 2 would give us positive 24. Times negative 2 would give us negative 48. Times negative 2 would give us positive 96. So because it ends up a positive at the end, when we multiplied by a negative 2 instead, there is a second answer for this. So yes, r, let's make it a lowercase r, could be negative 2. All right, so table 4, I'm going to let you guys do on your own because it follows the same path. So see if you can figure out table 4. Then flip to the back. So the method we used was the first term given multiplied by the ratio. And in the exponent, it was the number of times the ratio is applied. So how many times we multiplied by the ratio, and that's going to equal the last given term. So I have to extend my page a little, but that's going to equal the last given term. So how can you tell if there's going to be more than one solution for the geometric means? It's either going to be a positive or a negative. So if you get out a positive root, so when you solve for that ratio and you get a positive number, try a negative of the exact same number. So if it's a 2, try a negative 2. If it's a 7, try a negative 7 and see if it still works in the table. All right, there's an assignment on Canvas that you guys need to complete now.